So my plan is to do as many as I can of these wire patch kinds of tutorials. So if you have any questions, if there's anything that you can think of that you would like to see specifically, let me know. I want to know about it. I want to be your guys' premier, wire tutorial guy. I want to be that guy, right? So if there's a question you guys have, I want to know about it. I will try to go out of my way. If I don't understand it, I have resources. I'll be able to pull from somewhere else and try to understand it as best as I possibly can to bring it to you. The objective here is to give a better understanding of Resolume Wire, uh, to give it like a description, or not a description, a thorough kind of understanding of how the nodes work and some of the processes behind the scenes that has less to do with the actual nodes themselves, but how to, like, practical application, basically. What can you use the application to do? What kinds of things can you create? And then also how much of this actually applies to other programs. So today we'll probably be talking a little bit about masking, but we'll also be showing how masking is important and what kinds of things that this particular wire patch can do for you. And I think we're pretty much ready to start. Okay, I think I'm going to start here. However, I just want to preface this a little bit. Thank you very much for watching this second tutorial. Jesse has been an amazing person to give me this opportunity to kind of speak to you guys, to talk to you about how Resolume works, or Resolume Wire works, how we can make the community understand how Wire is integrated into Resolume, and how you can use it as a tool for your creations, for your Resolume arena and avenue. So that being said, I also want to just kind of give you the ability here. If you have a question, if there's something you guys don't understand, just try to, let me know, flag me down. There should be an option to allow me to kind of see a question hand go up. However, if you don't, or if you're not able to do that, if you get a hold of Jesse, Jesse has the ability to speak in here and just kind of chime in. He'll be able to let me know if there's something I don't see for whatever reason. I would like to know, if you have a question, stop me then, because somebody might be asking you, or the same question you're asking, somebody else might be thinking. And I need you guys to ask me these questions, because without this input, I'm not going to give you the full understanding that you're going to want. And that's what this is about. If you don't understand something, I want you to know, you want to know about it, I want you to ask about it. All right. So without the further ado, just want to, uh, welcome you to this second tutorial. This is about the pixelated distortion. Pixelated distortion was an idea that I could, in theory, take an image, a media source. In this particular case, we're using the test Resolume like video feed. That's just an example feed as it's running the multiple colors, and it's running the time, and it's giving that slide that goes all the way across the screen, right? And so this is just any generic graphic or animation that you have. This is their test sample that we're running, right? So this is not just that it's this is not what your content is, but this is where your content would come in. Okay. And then by the end, this is what we're creating. What we're doing is we're actually distorting, in a sense, where we're making like multiple copies of the same media, and we're just offsetting it in different directions so that it looks like it's distorted, right? So when I go in here, there's an option to distort the circles, right? And as I pull back on this, it's going to distort them even further, and it increases the size of the background, but then it also distorts the layers on the left and right and top and bottoms out, so that they don't line up properly. And what I'm doing here is I'm actually using a masking in order to make that happen multiple times, to distort in different directions. And I do this because this is kind of like this just a unique look. It gives it this kind of like textured circles, but you also have the option for triangles, for example. There's the option for just distortion itself, where it's taking those and just using just the square blocks, and it creates this kind of random distortion. This random distortion is created using a mask system, and I'm going to go through some of that today. We'll talk about some of the different options here and how they work. Right at this moment, this here, right here in this pink, this is just for the audio reaction. In a lot of my patches, I like to give the people the ability to change the way in which they have the audio reactivity set up so that it reacts it's specifically to your show, however you want to set that up, right? So I'm gonna scale this back just a little bit to bring it more into focus, right? So what this does is this is just your like it's a way in which to tell the system every time you hit the trigger or every time there's a transport beat or every time the metronome triggers to basically attack and a release. An attack and a release is just kind of like a true or false value, and it's pulsating, right? And it only happens within a certain amount of time, right? So right at this moment, it's set for just trigger. And if you notice, I'm going to scroll in just a little bit here. If you notice it's set for just trigger, so if I hit just the trigger, you'll notice that over here on the gate and on the attack release, you'll notice that the lights light up, and that basically lets you know that it's triggering that information. Now, you're not going to be able to see that very much here because the fact that there is a static noise that's just moving on its own. It's constantly moving. So if I turn the static speed to 0, then I hit the trigger, you should notice that it moves just a little bit. And that's because it's just the trigger that's activating that speed. Uh, so, so a little bit about how these are set up. These three options here on the left are actually inputs. So if you double left click on any space within wire, as you double left click, you'll have an input. And as you look at your inputs, here are all of your Boolean in, your float ins, your color ins, your scalars, your slice ins, all of them, right? These are all the options, your inputs that you can bring into the program that will allow you to give access to the user on their screen within Arena and Avenue to be able to slide to make these sliders so that they can adjust your patch or the patch, whichever patch, if it's your patch or if it's a patch that you've distributed. So, like for instance, I'm going to do color in, right? COLOR in. And when I do that, I'm going to get this option, which is my color input. If you scroll down here at the bottom, it puts it down at the bottom. It usually does this in a like it has to do with where it is like visually, but you can move these. It's not like they're specific in a specific order. You can move these in your order as you see fit. Okay, so this one does color in, and it gives you all these different options to choose from. That you can choose your colors. You have your red, green, and blue RGB, and then your HSB, which is your hue, saturation, and brightness, right? So this is just an example of an input that you can give somebody else to be used within Arena, and that's likewise that's what these are here. This one is a float in, I believe. It could be an integer in. I'm not really. I'm pretty sure it's a float in. If you go to integer in, you'll notice that there's a slider here. Okay, so if I go into the integer in, there may be an option. There's an option that we're looking for, unit max. It is not. Okay, so then this is a float in to give you so an integer is basically that. It's just the difference between a float and an integer. If I go float in, is that the float in, whoops, bear with me one just second. So your float ins are a decimal value or it's not just a 1 to 0, it's a 1 1.1, 1.2, 1.3, or 0, 0.1, 0.2, 0.3, 0.4, and all the other points in between, right? So the values are different. You'll notice that, like, for instance, this number, if you look at this number right here, you'll notice there's a decimal point for float ins. Okay, and that's a singular float. An int in, or an integer in, is that just those two values. It's just 1 or 0, right? So that's the differences between the two. There's more to that, but that's the short version. So if I were to go to this option over here, this node option here, I have the ability to set this to anything. So this is a max count of 30, right? And so this integer will go from 1 to 30, but you'll notice that it's counting in increments. It's counting from 1 to 30. It's not counting 1.5, 1.7, 1.76, 2.54, so on and so forth. Okay, so that's how that basically works. So to go back to what we were talking about before, this has the option of a drop down. What they've done is, in the latest, one of the very newest versions or newest patches of Wire, they've basically taken out a option before you actually had choice in, I believe it was, and so now they've basically added it into the float in. It made more sense to them to make it that way. So if I go into my nodes and I go to options count, my options count right now is set to 0. If I set this to 2, you'll notice that now I have two options. Option 0 is always the first option, and the reason that has to do with a programming kind of language behind the scenes. Your first option is going to be 0, and then the second option is going to be 1, followed by the next to the next to the next. So it would go 0, 1, 2, 3. If you wanted four options, the first option is always 0, and so that's that particular part. So then what this does is it allows you to set a value. So, like, for instance, right now I have this float in. The float in can be any kind of name. So I could call this, options, right? Oops. Except if I knew how to spell. Okay. So option one and option two, I can change the labels for those two options if I so chose to, but the value is 0 or 1. And as you notice here, I'm going to remove this one because we still have this one here, which has three options. Okay. But you'll notice it's attached to a gate, and the gate is basically saying, which value do you want? And when you select the trigger or select the drop down box, you have the option for all three. And when you look into the selection, you'll notice just trigger is value 0, the transport beat is value 1, and the metronome is value 2. So it's going case 1, case 2, case 0 is related to the drop down, right? So if you hit 0, it's going to go to case 0. If you hit 1, it's going to go to case 1, so on and so forth. So that's how you basically create a drop down option. So you can choose between the three options. So that's a little bit about how the attack and release has been set up. This is for the video, and I'll show you a little bit more examples of this. For the time being, I'm just going to set this aside for right this moment. It's set to just trigger because I don't want it to trigger our effects. So we'll go through that in just a little bit. So this section is very similar to what we were looking at last week. Okay. And I know it doesn't look like it, but it's very similar. If we go here to our fractal noise, you'll notice that this is just a noise. Excuse me. This is very similar to what we saw last week, which is it's a noise effect. It's creating a random set of points. And in this particular case, we're using a value noise, not a Perlin noise or simplex noise. There are different types of noises. Noises is nothing more than just static itself. So it kind of looks like this. Okay. However, its softened edges create this. And basically, the static is nothing more than like this pixelated at a larger scale, and then they create a blur. The short version is they create a blur in the background, and then they basically take out the values. They shorten the values of black and white, and then you get this kind of like softened edges kind of area. If you want to know more about this, let me know. I could fill your head full of all kinds of craziness when it comes to noise and how noise works. It is very interesting to me, but just know that noise is like it allows us to create textures and all kinds of different things. And in this particular case, it's being used as a way to filter in with the static that I have here. Just like we were doing last week, the static is actually being transformed to a certain kind of speed so that it's not going too fast. As a matter of fact, I'll increase the speed so we can see a little bit more. So basically, what I'm doing is I'm just basically creating an oscillating kind of shrinking and contrasting and expanding noise. Okay, so here we actually have it mapped. So it's going from the attack to the release, right? And so it's just going from 0 to 1. And what's happening is here is where it's expanding and contracting. This is a scene or a sin. It's an oscillating kind of value. It's going from 0 to 1 to 0 to 1, 0 to 1, so on and so forth. And you can see that if I highlight over any kind of node, in most cases, you will see like the value that's being outputted from that node, right? So in this particular case, you'll see it go from the 0 value to the 1 value and decimal, and it's being added to the map, which is coming from our attack and release. So our attack and release will add to that value if it's activated. In this particular case, right at this moment, it's just the trigger, right? So if I come down here and in this add, if I were to then scroll to the beat trigger, if I hit the beat trigger, you should be able to see the value change. If we shrink that down and then hit just trigger, it's very, very subtle in this particular case, and you may not be able to see it here. But it just kind of moves just a little bit. And what that does is it gives that person the ability to make like actually it might be easier to see here. I don't know if you can see that. It's changing just on the fringes, right? And it's just kind of just a little bit of pulsating. It doesn't look like much, but it is something. So if I move my static speed up, you'll notice that now we get a real kind of speedy kind of look. So to kind of explain how this is working, we're using that oscillating scene to make this expand and contract. And what's happening is it's just basically going from 0 to 1 value on the scale, right? So it is the X and Y, which is a float 2. Float 2s are meant for X and Y. That is for your vertical and your horizontal. In this particular case, the vertical and the horizontal is of the vertical scale and the horizontal scale. And I'm basically you'll notice that the add is going into the X and Y values at the same time. The reason for this is because we wanted to expand at the same rate as the expansion on the height as it is on the width. So it's gonna do this kind of pulsating breathing thing, right? And so that's the reason why you're seeing that go through the transform. The static, which is this, is in the transform. The transform is just doing nothing more than just this. It's just expanding and contracting. The pixelating is doing like we were doing before. The pixelating is just basically making the static a larger scale. Okay, but if you notice, we're not transforming after the pixelate. We're translating before the pixelate. So just kind of think about this. When you're doing this, we're only changing the fringe the most, but the stuff that's in the middle doesn't change as much. So this is a very unique way of doing this because then the things in the middle stay a little bit more stationary. As you can see, the corners are changing the most. And this was on purpose because I wanted to give that feeling like the middle is just kind of slowly molding, but the outer fringes are just acting like they're going everywhere, right? And so that was the premise behind this. So now we have these two processes running in tandem, okay? We have the static like we were doing last week, we have a static that's running, and then we also have a fractal that's running. It doesn't look like it's running, it's slowly moving, it's very, very slow, okay? And these two are going into what's called a crossfader, and the crossfader is is right at this moment, it's at point 2, so it's almost in the middle, right? If I were to put it in the middle, you'll notice that we have these dark areas and then we have these light areas. This is gonna become important and later on, okay? But what's basically happening here, the reason why we're doing this is because we want to be able to control these areas that are in this particular scene. And we'll make this a little bit easier to understand. We'll go to circles because circles is probably the easiest to kind of wrap your head around. Okay. I'm going to go to the join. Actually, we should probably go to like a mask. That's kind of hard to understand. Okay. So let's do this. Let's go back here and we're just going to quickly go over this a little bit. So I have 4 different objects. Okay, I have 4 different objects that I want to change to a specific shape, right? So I have 4 different shapes, and I want to use only those 4 shapes in this pattern. So in the areas where there's white, I want big circles. Where the areas where there's gray, I want slightly smaller circles. Where the areas where there is a darker gray, I want even smaller circles. And where there are areas where there are black, I want the smallest circle. Okay. And the reason for this is because I want to be able to control the way in which this pattern shows up. So what I did was I created this posterize. This posterize breaks down this crossfader into 4 shades of gray, or black, white, and 2 shades of gray, I guess you could say, right? The reason for this is because this is our grid. We are using this system here to grid out our our shapes. And I'll show you in just one sec. But to kind of give you an understanding, I don't want to skip over this particular part, right? There was a time where the pixels, each of these small little tiny pixels were too small to me, okay, or they were too large for me. And I wanted a way to be able to shrink that pattern down. So what I did was I actually created repeats. Okay, and the repeat is basically this here. You'll notice that there's this line here, and that's because it's creating that same pattern over. So the left side, left quadrant of the screen, and the little sliver of the right side of the screen is the repeat, right? And the reason being is because I wanted to create this shape here to give us a little bit more pixels to work from. And there's a reason for that is because when we come to here, we're going to have this as our template. We're going to use these gray circles, excuse me, these gray squares as our template to the circles that are going to be on the screen. So let's talk a little bit about the circles. We've kind of briefed over that a little bit. If I go to these here, okay, there are 4 sets as you can see. 1, 2, 3, 4. 4 sets of blue. And every 4 and all 4 of the cases in all 4 of the cases, I actually have a switch that changes from circle to triangle and then to square as the final choice, which is down here. This is the square. Okay. In the square example, the only thing that changes with the square, the shape does not change itself. So it's just to basically use as a mask. This is all using a mask system, and I'll show you in just one second what I mean by that. But basically, this is the square, this is the circle for the first set, and this is the triangle for the first set. And then down here, I have the same kind of thing going on. But as you notice, we were talking about circle size. If I go from this circle to this circle, you notice that this circle is a little bit smaller than that circle. It's not much. It's very, very small, very, very minute changes, zero point 0.8 versus zero point 0.7. And down here, zero point 0.5. So actually, I could probably shrink this down even more. I could go 7.5, or I could go to 6.5, right? Or 6.8, right? Because that'll be this will be just small enough that you can actually see a visible change, right? And if I go down here, the circle's even smaller. And then the triangles, the same kind of thing going on. If I come back up here, the triangles are not changed by size, the triangles are changed by direction. So in this particular case, the triangle's on the right. This side, the triangle, this one, the triangle's on the top. This one, the triangle is being mirrored on the top and the bottom. And then finally at the bottom, they're just at the bottom. Okay. So just four different random patterns. What I'm doing is I'm actually taking those three different patterns, the circle, the triangle, and the square, and I'm giving you a switch to adjust from. So you basically have, just like we did with the transport beat, the metronome or the trigger, I actually have that here as a form of way of changing. Okay, so you can select a different option, and it will basically choose between those three shapes. I put those through a shape renderer to basically, this is for resolution. I do this on purpose because your triangle and your circle are shapes, and I'm basically trying to basically whittle that down a little bit. So your shape renderer also gives you the option to change colors within shapes. Uh, so within Wire, you actually have the ability to make shapes that are vector in format, and then you're basically taking those vector formats and then you're creating like a raster image of those shapes. Typically, not always, but the short version is there's options to make shapes. We'll just stay with that for right this moment. Maybe we can talk about that in another tutorial. The differences between the two and how they work. But in this particular case, we're just going to say the shape renderer is just a way for me to basically take all the components of each of the shapes and condense them down into one shape instead of having a triangle on top of a square and then those two trying to like be added to the merge, which will make sense in a second, because I'm going to make a pattern from this merge. Did you notice that when I went from shape renderer to merge, you'll notice that it kind of stretched it out? And the reason being is because it's combining them as one, but then it's using the relative size. Because what I'm going to do is I'm going to basically take that shape and I'm going to squish it back when I use my Mesh 2D. My Mesh 2D is creating all of those triangles in a grid system. This is where things are going to get fun. Okay, if I lose you, please raise your hand. I am using the shapes down here, this pixelate. Each one of these little individual squares that you can see, all the black ones are separated, all the gray ones are separated, all the light gray ones are going to be separated. And hey, yeah, all the white ones are also going to be separated. And what this does is when I create this, it creates these individual different patterns. So if I go to this one, if I go to this one here, it's a different pattern than the one that you just saw. And then this one here is even a different, more different pattern. And then finally the white at the top, right? So I have white, I have the light gray, the dark gray, and the black at the bottom. Okay. What I did was I took my pixelate and I created a grid, and then I also created the same grid system in a Mesh 2D. Okay. There's a reason for this. I took this shape here and I masked that so that you would only see just the ones that are white. So all the areas that are empty will not show up here. Does this make sense? I'm basically using those withins to create a masked image of just the triangles themselves. This has some serious implications or implications for other programs. You can do some crazy things with this. If you know how to create this grid system, these don't have to be triangles. They could be circles, they could be diamonds, they could be squares, they could be any kind of shape your heart's desire. You just have to figure out how the shape is created, put it on a grid, and then once you put it on a grid, you're masking those areas. So then what you do is you mask the different areas. You take those separations and you create uh, different masks from the different areas. So here are all the dark areas with the little tiny the triangles at the bottom. Here are all the ones where it was mirrored top and bottom. Here is where it was just the triangle at the top, and then here finally is the triangles that are on the right side. So I'm using the mask that I created from the grid from the Pixelate, and I'm making a within to select those colors and then making that into a mask for the triangles. So once this is done, I'm concerned that I'm people are like, now what did you just do? It's like a digital lava lamp. Yeah. So what I did was I used this as a way to merge them together. So okay, so here are all these triangles, right? And you'll notice that, okay, I've got these triangles. I could change these as a color, right? We have this shape renderer down here at the bottom. We don't have to go through the rest of this, but the short of it is, or we do have to go through the rest of this, but there was a method to that thinking. I'm sorry. So, but let's just talk through this particular part. What this particular patch is doing is it's taking the texture, it's basically hub is nothing more than the texture itself. So I could take this off here and I could put anything in its place. This is just a placeholder for the texture in, like we discussed last week. So this allows you to have like you could make this a picture, it could be an animation, the texture in could be anything. But it basically allows you to plug that in without having to reroute all of these lines that are connected to the hub. You could just take this off and not have to you could take this off and put your graphic, attach it to here, and then it's going to filter out to everything else. And I do that on purpose because then if I have something I want to test within Wire temporarily, I can just add it here and I don't have to worry about like reconnecting everything after I'm done with whatever I'm using. And then I can just put in the texture in and be done with the rest of this. So, but to get back to what we were talking about before, you'll notice that these are all connected to slides. Slides are basically a way for you to take the image and slide it left or right, top or bottom. It's repeatable, so basically what happens is the edge, as you'll notice here, is kind of cut, and that's the edge that was from this side. It just repeats it on the left and bottom in this particular case. I also, if you've noticed, have that repeated 4 times. So, and all 4 times they're moving in different directions. This one's sliding a bottom and right. This one's sliding left and bottom. This one is sliding top and right, and this one is sliding left and top, right? So then each one is moving in a different direction. And then what I'm doing is I'm using the triangles that I've created as my mask. So I'm masking a mask. I'm using this mask to create the triangle mask that you see before you, and then I'm using the slide, I'm putting that in a mask. So now I have the triangles that are basically masking or creating it's using this pattern inside of those triangles. And then what I'm doing is I'm adding all 4 sets together to create a join. And what I've done at the very, very bottom, or the very, very top in this particular case, is I've just added just the straight background. And the reason why I did this is because you don't want just a blank background. If I just unplug this one, see how this is just the triangles, the crazy mess of triangles. So here we have the mirrored triangles, we have the triangles that are from the bottom, and the triangles are from the right, and the triangles that are from the top, right? And if I add this in, this is the background This is the original image that I just basically put in this join. Before this was set up with a visual, this particular one was set up with a video mixer, and the video mixer just basically just it would slow down the system. Ask Jesse about that. He knows what I'm talking about. He tried to use this on a 4K, and it basically took his FPS from 60 frames a second down to like 10. And I was like, yeah, I think I got an idea as to why that's happening. Crap. Um, and here with these withins, you can actually do this a different way. So I use the within. Within, I should probably discuss this a little bit. You'll notice that this one's set to point 0.6 to point 0.8. So what you're doing in this particular case is you're saying with that render of the pixelate down at the bottom, okay, I want to see only the areas that are within this range of grayscale. Okay, so I only want to see the black ones. If I only want to see the black ones, I want to do within from zero point 0.2 to zero point 0.4. These are all your red, green, and blue channels, and they're all the same. In this particular case, for the lack of a the short version is all your minimums, your RGB and alpha channels are going to be set to zero point 0.2 and the max is zero point 0.4. So I only want to see the values of zero point 0.2 to zero point 0.4. Okay. And the second set, I want to see the values from zero point 0.4 to zero point 0.6. And in the third set, I want to see from zero point 0.6 to zero point 0.8. And in the fourth set, excuse me, I want to see zero point 0.8 to 1. Right? So I'm basically seeing just those values. I'm basically saying to the system, I only want to see within this grayscale, and I only want to see within this grayscale. Um, your float force. So in when you're using anything that has to do with GLSL or C++, there's this thing float force. We should probably go through this a little bit. This is a sidebar. Okay. So you have a float one, you have a float two, you have a float three, and a float four. Float one is just one value. Okay. Then you have a float two, which is your X and Y values. Did it put it in? It did not put them in. Okay. That's fine. I'll just do it again. Float. Let me learn how to spell. Here's a float. A float is going to have just one value. Okay. Your input is 0. You have a float two. In this particular case, it's XY. That's your X and Y, your vertical and your horizontal. Your float three is your X, Y, and Z. In this particular case, like we talked about last week, Z is kind of, it's not exactly what you expect it to be. Z is typically used for your in and out. Right? So X, Y, X is this way, I think, and Y is this way. I always get them backwards. I probably am backwards. It's probably X is this way and Y is this way. No, I'm right. X is this way and Y is this way. Okay. And then Z is in and out. Okay. In your three-dimensional programs. In this particular case, Z can be used for many different things, but in all intents and purposes, because it's GLSL code, usually typically you would use Z for that. And then there's float fours. Float fours are your red, green, and blue values. Okay. And the W is alpha. Okay. Your alpha channels. So if you have a PNG, that would be your alpha channel there. When you have a transparency, that would be the 0 or 1. If you have a color value, this is how it's going to be broken down. One of the things that's also kind of unique about this that is just kind of a general interesting. Aha! I never knew that. Did you know that your X, Y, and Z values are also kind of an RGB? Typically, when you look at your three-dimensional programs, you'll notice that your X is typically red. Your Ys are typically uh, green, and then your Z values are typically blue. And the reason being is because they're using an RGB value. Those RGB values also are a part of a UV map. If you've ever used a UV texture, this is kind of a crazy mess, but basically, and the short of it is that you have your red and your green, which make yellow, right? But in this particular case, they're talking about the x-axis, and the red is talking about the x-axis, and the green is talking about the vertical axis, right? Or horizontal and vertical. So typically, if you see a three-dimensional texture, they'll add blue to this. But in most particular cases, like for instance, if you're using Blender, and Blender, this is in Blender, okay? However, they typically move the 0 point instead of in the bottom left-hand corner, it's usually in the middle. So you'll see this black in the middle, and then there'll be a different value change. But it's virtually the same thing. It's just where the 0 value is in Blender versus Resolume Wire. Okay, so just kind of a sidebar. But in any case, let's go back to this particular part here. So we have this mask value. This mask value can be used for anything, right? There are plenty of different ways that you could set this up. It can do some really crazy things. In this particular case, we're taking all those values, we're adding them to a mask, and as they're added to a mask, they basically create this transform, and this transform is set as a texture out. And that's pretty much the gist of it. I'm sure there are going to be plenty of questions of how that works. Is there a MIDI mapping and wire? There is a MIDI mapping and wire. That is correct. If you go to input and you go to MIDI in, it'll give you the option to do a MIDI in. Like use a controller for knobs on the X and Y values. That is correct. You can send a MIDI value into wire specifically if you so chose to. Now, here's the thing. Typically, I don't set them within Wire, and the reason being is because most people will set them up in Resolume. And so therefore, I would much rather them set them up in Resolume and not get convoluted within Wire. There may be instances where I would want to set it up in Wire, and I can do that. There may be cases where you would want to do that. In my particular, what I create for my users or for the people, the people who are interested in what it is that I do, I typically leave that up to them in Arena or Avenue. But to give you an example, so some little bit tidbits about masking. How many of you guys actually know? How much do you guys know about masking? Do you feel comfortable with it? Oops, wrong thing. I just know what I learned about masks in Photoshop. That's very good because masking is very, very, very important within Wire, or at least I feel like it's very important in a lot of programs. It's not just Photoshop and Wire and Arena. Almost every program that's a computer graphics program will use masking, and there's a reason for that, and I'll show you. Color. We'll use a linear. We'll use a linear gradient, and I'm going to use data texture from data. Oops, wrong one. Data. And so I have my texture from data, and I'm going to use an expand, expand. Okay, so, and then I'm going to need a color. Let's use a colorizer. Oh, no, 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 shape renderer, because we're using shape. Okay, so actually we might not be able to do that because we want to change the color. Let's use the other one, colorizer. I'm going to explain this in just 1 second. Colorize. Okay, so I have a circle, and I'm going to plug my circle in to the colorize. It's going to change it red. Nothing really special there. You kind of that's basically it. I took the circle and made it red. Yay! Congratulations, you're all done. Anyways, so what I'm going to do is I'm actually going to add a gradient to this circle. So what I'm going to do is I'm going to use the linear node. I'm going to change it to color. it's gonna go from black to white, and I'm gonna drag that to my expand, which is just basically going to expand the number of colors that I have. So we're gonna scroll in here a little bit more so you can see what I'm doing. Okay, so I have my color connected to, or excuse me, my circle connected to the colorize. The colorize is right at this moment is turning it red. What I'm going to do is I'm going to turn this from color to palette, and then I'm going to use this linear color. As you notice, it's going from black to white. You have three different values. This is those floats that we were talking about just a second ago. You'll see a float 4 here, right? Because you have your red, your green, and your blue channels, and then there is the alpha channel, which is your float 4. That's what that is right there, right? So now you know that this is a float 4. But basically what I'm doing is I'm connecting it to an expand, and the expand is going to expand it by 20, right? So now all I've done here is I basically take this 10 the 10 values that are here and I changed it to 20. You can't really see all 20. There is a way to do it. I'm trying to remember what it is. I think there's like a button you can hit and it'll show you all 20. Is it right click? No, no. There is a way that you can actually physically see all the values. I'm trying to remember what it is. I think it's like you select the value. There's a button that you can hit. I'll look into that and then I'll put it in the notes. Thanks for zooming in. I couldn't read the notes before. No problem. So, okay, so even though you can only see 0, 10, and 19 right at this moment, there actually is all the values are here. There we go. Okay, so now you see 0 to 19, right? Because 0 is where we start. Even though it shows only 19, 0 is the first one, so there actually is 20. Okay. So what I'm going to do is I'm going to take those float fours and I'm going to plug it into my texture from data. And the reason why I'm going to do that is because I basically want a texture 2D so that I can plug it into my colorize. And what this is going to do is it's going to create a gradient from one color to the other. And actually, it may not. Let me think about this real quick. Actually, I think I want to do a colorize. I don't want to do a colorize. I want to do a mask or a multiply. So let's do this a little bit different. I'm going to do a gradient. Sorry, I don't mean to bounce around a little bit. So here's a gradient, and then I'm going to multiply the two together, right? So then we'll do multiply. And then I'm going to take the top one and the bottom one, plug them in together, and you'll notice now I have a gradient. Okay. I'm going to change this to black. No, change to black. There we go. And change to white. Ta-da! And now when I go into here, now I have from gray to white. It's not completely black to white, but it's close enough. If I plug this into my mask and I just grab like what do I want to grab here? Let's do a noise. So I got fractal noise. Here's my fractal noise, and we'll just kind of bump up the channels so that it's at least something different, and we'll give it a little bit of, so you can really see it's pretty colors. Okay, so now if I plug this into here, you'll notice that I have a gradation where I'm going from, you can almost see like there is no transparency at the very top, and then it's transparent as it gets closer to the bottom. And the reason why is because there's this gradient. Anything that is black in a mask is going to create a transparency that you can see through completely. You're not going to be able to see any of those colors in this area down here at the bottom. Anything that is white, you will see, and it'll be completely opaque, and you'll be able to notice that it's there. So in this particular case, the top is going to be able to be seen, and the bottom is going to be kind of semi-transparent because it's not quite black. Okay. So that's how that is particularly working. If I set it in levels, I think I can do it with the levels. Let's find out. So if I take a levels and I shrink this up here and I drag this down and try to change the midtones a little bit. This is similar to the levels within Photoshop, this levels option, but just know that it's not the same. The levels values within Photoshop is much different. but it's similar. It has similar kind of reactivity, but it's not completely 100%. So, for instance, if I move this up, it's hard to get a hard line to get a like a value that's not like you'll notice that my line is not completely black and it's not completely white either. And as I drag this one down, it's harder to control. Mine looks a lot more pixelated for gradient. Does that matter? Yours looks a little bit more pixelated for the gradient. It could be because you're using your if you go to your patch and in your patch, does your patch say what texture does it say? That could be one of the reasons why. If your texture bit depth is too low, that can create some pixelated in some cases. Also, the same kind of thing within your multiply or your other nodes. Sometimes, like I'm trying to give you an example. Like here's an example, right? My bit depth here is set to patch bit depth. I can change this to 16, which will make it better and it'll improve the quality of the graphic. However, with great power comes great responsibility. Know that when you do this, it's going to make it it can drastically change your FPS. Just know that. So you'll notice that now because I've added in this levels and it's basically the value of dark starts sooner, you'll notice that now everything below is transparent and everything that's at the top is is able to be seen. And as I move this value, it really changes where those values are, right? So this is the power of masking because if you understand how this works, you can do some crazy things. Let's take the fractal noise, for example. I'm going to make a second copy and I'm just going to change that down to 0, right? So now I just have straight black and straight white. If I plug in that straight black to straight white into this area, and then I use that as my mask for my other fractal, notice that it took all the areas that are black and made them transparent. And the places that are white are showing the colors through. So if you know how to really kind of um, use this, this works when you're using like for instance, if I take a picture from my desktop, we'll say, let's see if I can find something that's like cool. Like cool. Gotta find something that's got a gradation to it, just an image. Sorry, I didn't come prepared. Oh, wait, can I use this? This will work. Okay, so for instance, now this is my gradation, right? If I take this and I plug this into here, everything that is black is going to be transparent. I'm going to actually have to change that, but you get the idea. This is a little harder to understand. Let me see if I can find something that's already 1920 by 1080. But basically anything works if you have, well, I could use texture in, right? If I scroll out, um, here's my texture. If I plug that hub, I could make another hub, or I could just there. Okay. So now I'm going to take this hub and I'm going to plug it into here. And the reason being is because I want to use that Resolume texture. So the area that's here, the white is what you're going to see. If I go to the mask, you'll notice that the white is the area that is not see-through. All the areas that are light gray, you can actually see through. So if I actually took this gradient and used it as a background. So if I did a join and I use that as the background for the mask. Okay, so here's the mask. If I change these colors, like if I change this to like blue and I change this to red, it's probably a little bit easier to see. You'll notice that the blue is starting to show through where there are the transparent lines. The area where there's the white resolume is the most clearest. It's the one that's not transparent at all. But the areas that are gray are see-through. It's hard to see in this image. I should probably use a different image, but that is the gist of it. Any picture that you use, if you translate it to just your straight black and your straight white, There are so many applications that you can use that for. But in masking is a perfect example. And masking, it allows you to do many different things. And that's because right at this moment, we're on the luminance channel. The luminance is taking a gradation value or a grayscale value. You also have the option to do red, green, or blue. Red, green, or blue is another a topic for another day. I will give you a short version of that is if you had an image, let's just say a Photoshop image of something that had color. If you hit red, it would only take the values of red and black. Anything that was red would be able to be would be opaque. You wouldn't be able to see through it. Anything that was black would be transparent. You would be able to see it. But all the other colors, like green and blue, would also be transparent because of how it translates that image. Can I show an example of that? If I plug this into mask, so there's the red, here's the green, and here's the blue. There's a thing called channel masking, I think is what it's called. And it allows you to create all kinds of unique and crazy stuff because you're just changing the color values of red and green and blue. And if you know how to adjust that in an animation, you could add it into this. And then you're masking specific areas with just a translation from or transparency or a transition from red to green or blue to green or red to blue, so on and so forth. So it's an interesting way of controlling your visual effects. So that's a little bit of an extra little area if you guys are interested. So that's pretty much it for today. That's those are the kinds of things that I wanted to kind of give you guys an understanding about and how that kind of helps to create this patch.